The Norwegian Maritime Directorate decide the requirements for stability at vessels, and these requirements are normally found in the regulations for the type of vessel. The requirements for stability, minimum requirements, they depend, among other things, of the type of vessel, the size of vessel, and in some examples also the sailing area of the vessel. We're going to be looking at requirements for fishing vessels of more than 15 meters length from the regulations. And there the stability requirements are found in paragraph 3-2. There's a number of requirements. To understand some of them takes you need a higher level of education, but we're going to look at some of them. First, the righting arm should be at least 200 millimeters at an angle of heel equal to or bigger than 30 degrees. So at 30 degrees heeling angle, you should have minimum 200 millimeters righting arm. The top point of the righting arm curve, the GZ max, should be at an angle of heel that preferably is bigger than 30 degrees, but under no circumstances should be less than 25 degrees. So the top point should be at more than 25, preferably more than 30 degrees angle of heel. The GM should be no less than 350 millimeters, 0.35 meters. And the GM in light conditions, so the light ship GM, should be positive. For fishing vessels with a length below 24 meters, in addition, you have a requirement that the righting arm, the GZ, for angles of heel between 40 and 65 degrees should always be more than 100 millimeters, and it should be positive up to 80 degrees. This means that the range of the GZ should be at least 80 degrees. As we can see, it should not go down to 0 again at a heeling angle of less than 80 degrees. Summarized, B, that's the center of buoyancy. We can think of that as the center in the part of the hull that at any given time is submerged in the water. So when the vessel rolls or pitches in the sea, the B moves around. G, center of gravity, which is the center of gravity. K is the keel of the vessel. M, the metacenter. That is where the vertical force upwards from the B cuts the center plane of the ship. And GM, metacentric height, which is the vertical distance between G and M. GZ, righting arm, when a ship heels over and the B shifts sideways, as a result of that, you get a GZ, which tries to righten the ship up again. KG, VCG, is the center of gravity height above the keel. And Km is the height from the keel up to the metacenter. All ships are required to have information about their stability with limitations, operational requirements, etc. This information should be approved by the authorities. In Norway, that's the Norwegian Maritime Directorate, and is normally presented to you in a booklet, stability manual. In addition, many vessels have computer programs that are used to calculate stability when you're loading or discharging the vessel. Now, the stability booklets of any given vessel are very comprehensive, can be hundreds of pages, and they are not always that easy to read, to say the least. They are pretty much very difficult. We are going to have a look at some of the information that you can find in these kinds of stability booklets. One of the things we're going to be looking at is KG max, VCG max. And VCG max is the maximum permissible height from the K to the center of gravity, where you don't break any of the stability requirements. For us, it's vital to know where is the G? What is the vertical center of gravity? Vertical center of gravity should always be smaller than VCG max, kg max for our displacement. In the stability data for the vessel, we will find conditions where you have a description of how the stability of the vessel is in a certain state of loading. And also how big margins you have to the VCG max. And how these data look, they vary with the size of the vessel and also with the type of vessel and the regulations for the vessel. For smaller vessels, you may only have a stability poster, but for bigger vessels, you normally have much more comprehensive data. A stability poster for a small fishing boat can look like this, has basic description, graphic description of what you can do and what you can't do, what is okay, what is on the border, and what can't you do. At the bottom of the picture, you can see some limitations regarding how much deck cargo you can have, how much fishing gear you can have on board, but it also says for more information about the stability, have a look in the stability manual where you have conditions. And in the stability calculations for the vessel, you will see, among other things, the kg limiting data, which is the kg max, VCG max. You start out with your own displacement or draft, and based on that, you can take out trim, km, kg max, different information. And as you see here, km equals gm plus kg. So this is interesting information you can take out from the kg limiting tables for this vessel. This means you can calculate your kg, you can compare it with the kg max, and the actual kg should be at all times smaller than the kg max. Another example of stability data is a deadweight scale, which is also common, which gives graphic access to many relevant numbers and factors. You enter the scale with your displacement or your draft, and then you can take out values. So let's say that we have a draft of 1.7 meters. Then we can see here that we have a displacement of about 52 tons. The km is about 8.54 meters, and there's also other values we can take out here. The loading conditions for the fishing vessel on the picture here, called Støkurs, has lots of different, actually 20 different conditions. And the conditions vary the regards of fuel and consumables on board, varies how much catch cargo you have on board. So you have many different conditions, and you can see in the table here what is the displacement for the different conditions, what is the longitudinal center of gravity, what is the vertical center of gravity, and what is the transverse center of gravity. And for every one of these conditions, you have a complete list of all the weights on board, and you have the G-set righting arm curves. And we're going to have a closer look at condition number 19. Where you see here all the different weights in tanks and holds on board with centers of gravity, specific gravity for liquids. For tanks, you also have a load percentage, how full the tank is. And you have summarized at the bottom total weight for this condition, 389 tons. And then you see this compared, where you compare the actual kg, actual VCG, with the VCG max. We see the conditions VCG is 3.051, whereas the max allowed VCG is 3.284. So you see you have a bit of margin there. And also for the list of conditions, you can also see the column to the right, remaining VCG. So you have for every single one of these conditions, you can see how much safety margin do you have up to the VCG maximum? As we've seen, it's fairly simple for us to calculate where our center of gravity is. We put up a table and we put in the weights and calculate the moments, and then we can find the center of gravity. The actual G that we calculate, we can compare this with the kg max or VCG max values for our vessels, which we for many vessels will find in the stability data. And by comparing these two values, we can easily decide whether our stability is good enough. If the actual VCG is smaller than the VCG max, thumbs up, go ahead. On the other hand, well, you need to do something. And we're going to have an example with a small fishing boat here. Before she went out to the fishing grounds, she had a displacement of 10,400 kilograms and a calculated VCG of 1.4 meters. After pulling in the nets, you have about 300 kilograms of wet fishing nets on board with a VCG of the fishing nets of 1.7 meters. In addition, you have 1,600 kilograms of fish in the cargo hold and 300 kilograms of fish on deck. We're going to calculate a new VCG and see if it's inside the requirements or the limits for the VCG max. Now, how are we going to attack this kind of problem? Some of the data is given and some of it we need to go into the stability data to find. But in any case, we're going to use the table method. So, looking at the stability data, we put up the table, we insert the displacement at departure, we add the weights for the nets, 300 kilograms, kg of 1.7 meters. For the cargo hold, we use a vertical center of gravity of 1.24. This we can find in the stability data. For the fish on deck, we use the vertical center of gravity for the cargo hatch, 1.878. With this done, we can calculate the moment, weight multiplied by arm, and we get the moments in ton meters. Summarize the weights, summarize the moments, and the new vertical center of gravity is some moment divided by some weight, in this case 1.4 meters. We then check the VCG max for the displacement of 12.624 tons, which is 1.511 meters, we can see. So we have a safety margin of 11 centimeters in this case, which is good.